Hello everyone, and welcome to the vodcast to help you out with the Unit 4 study guide. So we're going to go ahead and get started here by just looking at the first few problems here. So question number 1 says, list all the rules for naming molecules, and then name or give the formula for the following. So I'm just going to kind of copy this little area right here. And let's see if that looks nice. There we go. So we're going to list all the rules for naming molecules. Alright, there's only 3 rules, so it's pretty easy. Rule number 1, the first atom only gets a prefix if there's more than one. Only gets a prefix if there's more than one. Rule number 2, the second atom always gets a prefix. Even if there's only one. Alright, rule number 3. The last atom has to end in an "ide." Okay. So for this first example, the first atom would only get a prefix if there's more than one. There is not, so we're just going to say carbon. But the second atom will always get a prefix even if there's more, or even if there's only one. So we're going to put that prefix for mono because there's only one. And it's monoxide. And how do you do that? Because if you put another O here, it's not going to be monoxide, it's going to be monoxide. Like moo cow. So get rid of one of those O's so it's monoxide, okay? Alright, let's go to the second one. The first atom only gets a prefix if there's more than one, and there is, so we're going to use the prefix di. This is hydrogen, so I'm going to write that out. Dihydrogen. The second atom always gets a prefix even if there's only one, so we're going to do that monoxide thing again. And that's water, dihydrogen monoxide. Alright, looks like there's 2 nitrogen, so I have to use my prefix di. Let's say nitrogen. The last guy here, looks like there's 6, so we're going to use that hexa. And this is fluorine, but we're going to turn it into fluoride. Oops, I spelled that wrong. Okay. Next one, carbon tetrafluoride. There's no prefix on the carbon, that means that there's only one, but there is a prefix of tetra. Try to remember what those prefixes are. Tetra means 4, so that means that there's 4 fluorines. Sulfur trioxide, again, there's no prefix on the sulfur, so that means there's only one, but there is a prefix of tri on this oxide. Tri is 3, so that'd be SO3. The last one, di. Di means that there's 2. I'm going to do this one over here, I ran out of room. Di means 2, and then the tetra is 4 and chloride is chlorine, so we're going to do like this. Notice in these samples that I did not have to worry about any charges when I was writing those formulas. That's why I like doing molecules. They're really easy. That was question number 1. Question number 2 is fairly lengthy. First I'm going to talk about the rules for naming these acids and molecules. We already got the rule over here. If you look, we already have the rules for naming molecules. But for this example, what I'm going to do is I'm going to also add the rules for acids off to the side. So let's do these first few, A, B, C, D, E, and then we'll do the other ones here in just a second. Alright, so first let's review a little bit about the rules for acids. There's only 3. The name of the ion will determine the name of the acid. So I'm just putting these up here. You will have to memorize these for the test. An ion that ends in "ate" is going to turn into just a suffix of "ic". Something that ends in "ite" will have a suffix of "ous". And an ion that ends in "ide" will have to have a prefix of hydro and then a suffix of "ic". So that one's kind of special. Alright, let's take a look at what we got. So in this first example, I want you to look at the first atom. The first atom is Ag. This guy is silver. Now if you look at silver on the periodic table, silver is located in the middle of the D block. Typically metals in the middle of the D block, they can have multiple charges. But silver is pretty special. In fact, most of you guys probably have some silver jewelry. It's a fairly stable element. In fact, it's semi-precious, right? Silver only has a +1 ion. So normally on these guys what we would do is we'd have to put Roman numerals to indicate their charge, but because silver is special, we're actually not going to do that this time. So, sorry, hold on. My eraser's not working. Hold on. So we're not going to do that this time. We're not going to put Roman numerals on silver. So now let's look at what's left. NO3. It looks like a polyatomic ion. So you would look that up. Don't say like mononitrogen trioxide. That's terrible. This is a polyatomic ion, okay? So you've got to remember that ionic compounds do not use mono, di, tri, those prefixes. You will not have those. So you're just going to look up NO3. That's called nitrate. Alright, so there's part A, silver nitrate. That's A. Alright, B is this next guy. I want you to notice that you have a hydrogen in the front. Anytime you see a hydrogen in the front, you have an acid. But the hydrogen in the front doesn't help us when we are trying to name this acid. So let's look at what's left. ClO2. You would have to look up the name of this ion to figure out the name of the acid. Since it's an acid, we're looking at this. We need to figure out what kind of ion we've got. So ClO2 has a name. What is it called? Is it chlorite? Okay. So if it's chlorite, we are going to chop off the ending here and replace it. See this rule? We are going to replace it with the us. So this is actually called chlorous acid. Chlorous acid. Okay. Sorry about my handwriting there. Alright, let's do the next one, part C. This guy in the front, this is copper. Copper happens to be one of those metals that is in the D block. And if you look him up on your list, you will see that he can be two different charges. He can either be +1 or +2. So what that means is that in this example, we've got to figure out what the heck the charge of that copper is. And the best way to figure that out, look at the negative side. Look at this. Because the positive and the negative, they have to balance. I'm sure you guys are familiar with this guy. His name is hydroxide. He's polyatomic. You could look him up on your list. He's -1. If he is -1, what does this copper have to be? +1. So we're going to indicate that using Roman numerals, and then we're going to end it with hydroxide in the back. So the name of that is copper 1 hydroxide. Alright, let's go to D. D looks like it's got a couple hydrogens in the front. Remember, the hydrogens in the front don't help us name it. It's actually the stuff on the back side that helps us. So CO3, polyatomic. You would have to look him up. I think, correct me if I'm wrong, is he carbonate? Cool. So if he's carbonate, look up here at your rules. He's carbon-8. We are going to call it carbon. We're going to chop off that 8 and replace it with an ic. So this is carbonic acid. Carbonic acid. Alright, let's do part E. In part E, we have this really strange looking thing in the front, NH4, and you see how it's wrapped around parentheses with a 2 on the outside? Let's figure out what the heck this guy is. NH4. He must be polyatomic because I see parentheses around him with a 2 on the outside. He's unique, and I've used him before. What's his name? He's on your list, that's right. He is ammonium. Now, I'm not making this up. Check out the Cr2O7. Check that out. He's on your list again. Is it dichromate? Yeah. Dichrome 8. This guy's ionic. Alright, let's keep going. Let's do the next set. I'm going to do F, G, H, and I. Alright. F. F has PB in the front. Do you know who that is? That is lead. Now if you find lead on the periodic table, he's in the middle of the D block. So I want you to look at that reactivity series thing that I gave you. I think lead can have 2 different charges. What that means is that we've got to figure out what the heck the charge of that lead is. And the best way to figure that out is to look at the negative guy again. Who is this? I think he's called Chrome 8. Am I right? CrO4? Yeah? Alright, what is the charge of a chromate ion, guys? I cannot remember, honestly. It's -2? Alright, if this guy is -2, what does your lead have to be? +2. So we're going to use the Roman numeral 2 to indicate that this lead has a +2 charge. And again, that ion's name is chromate. So there's your name, lead 2 chromate. The hardest thing for you guys on the test is going to be to remember the Roman numerals on the metals that come from the D block. Alright, let's go to G. Looks like you got 2 hydrogens in the front. Oh my gosh, I think this is a repeat problem. Didn't we have one just like this? Oopsies. That happens. This is carbonic acid. Just go ahead and put the answer in there. Alright, let's do H. Oh, guys, this is a terrible problem. I told you I would never give you a metalloid. This is a typo. I do not like this question. Maybe I was going for, I don't know, barium or maybe beryllium, but not just B. Hold on. This is actually a typo, so you can just cross it off. But why don't we give you a real example? Let's do BeCl2. Be is a metal. Now, B was a metalloid. That's why I don't like that question. I would never do that to you on your test. That's why it's a bad question. All right. So this guy right here, this would be beryllium. He's a metal. And this guy right here, this is chlorine. And even though you have 2, remember, beryllium's a metal. We don't do prefixes in ionic compounds. So don't start saying dichloride. Don't do that. This is just barium chloride. All right, I've got a hand up. Hold on. What's up? Is it 2 of the -2s? Oh my gosh, I didn't even see that, guys. Thanks for backing me up. Let's go back to F. I made a little oopsies. I'm so glad you guys caught that. Thank you so much. All right, this happens when I'm sick, guys. I'm so sorry. So CrO4 is a -2 ion, but I totally forgot to check. Look, you actually used 2 of those bad boys. So instead of it being -2, it's actually -4. Nice catch. Good job. Sorry, I didn't want to get that on the microphone. So instead of there being a 2 right here, I'm so glad you guys caught that. Ooh, big eraser. I don't want it that big. Let's see. Go down. Oh, it's as small as it gets. Okay. Alright, so that would make it lead 4 chromate. Yeah. Sorry about that. Okay. So we caught a couple weird things in there. Okay. Let's see. The last one is I. Let's do I. So you got carbon and hydrogen. Those are both nonmetals. And there's no hydrogen in the front, so it's not an acid. Finally, you've got a molecule in here. So the first atom only gets a prefix if there's more than one, and there is. So this is dicarbon. Second atom always gets a prefix, and that is hexa. Let's see if you guys know how to name this. It's not hydroxide. Do you know what it is? Hydride. Yeah, nice. Hydride. Okay, so dicarbon hexahydride. Okay, very good. Alright, write the formulas for the following and identify if they're covalent, acids, or compounds. So you see how up here we went from the formula to the name? Now we're going to go from the name to the formula, so this is opposite. Alright, here we go. Let's do these first ones right here, up to E. Alright, so this is A, nitrous acid. So you have an acid with an OUS. Do you remember what that means there? Ite. Good job. So this came from nitrite. We have to look up that formula. So nitrite is the ion that it comes from, and you would look that up and you would get NO2, and what's its charge? I think it's just negative. Am I right? So if it's just negative, when you make the acid, you always have to have a hydrogen in the front. And remember, you can have more than one hydrogen if you need, but we don't need to have more than one hydrogen because it's just a -1 ion. So since it's only -1, we're only going to use one hydrogen in the front. Part B. Copper 2 nitrate. What's this 2 after the copper mean? Copper can have more than one charge. That 2 after it indicates which copper you're using. Not how many you're using, but which one you're using. Copper 2 is actually a 2+ ion. Alright, who's nitrate? He's polyatomic, he ends in 8, so make sure you look at your list. He's NO3 with a -1. Now when I bring these together to make a formula, you always write the positive guy first, negative guy second, and notice that this is polyatomic. You see how there's 1 nitrogen and 3 oxygens? It looks like we also need more than one of that polyatomic ion, correct? How do I do that? Sorry, my alarm's going off. So if you need more than one polyatomic ion, there's a rule. You have to use parentheses. There you go. Keep your subscripts down low, and notice my formula has no charges in it. Let's do part C. Part C says phosphorus tetrasulfide. The dead giveaway that this is a molecule is the tetra. Do you guys see that prefix tetra? And another dead giveaway is that phosphorus is not a metal. It's a non-metal. So this is a molecule. Molecules are easy. Don't even have to worry about balancing charges. So the first atom only gets a prefix if there's more than one. Well, it doesn't look like there's a prefix at all. So we're just going to say P. Just one phosphorus. Tetra, do you remember what that is? 4. And then sulfide. Sulfide is sulfur. And it looks like you've got 4 of them. So there's your answer for C. Alright, part D. Ooh, looks like we have an acid. And you see this hydro in the front. Alright, that means that this probably came from selenide? 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 Huh, who's that? Any ideas? Selenium. It's actually an element on the periodic table. It is there. His number is number 34. You are going to need to try to predict his charge. So element 34, his symbol is Se. It is a -2. Good job, because it's 2 away from being a noble gas. So we're going to be placing 2 hydrogens in the front because he's -2. Hydrogen is only -1. There you go. Alright, E. Carbon monoxide. You hear the mono. Carbon's a nonmetal, oxygen's a nonmetal. You've got a molecule, so don't worry about balancing your charges. This is easy. There's no prefix on carbon, so it means there's 1. But there is a prefix of mono on your oxygen, so there's only 1 of those. Alright. Let's do the remainder over here. Okay. So the last one we did was E, so now we're on F. F is an acid. Phosphoric. Do you remember what kind of ions make ic? That's right, 8. Notice there's no hydro in the front. So we need to find phosphate on our list. Phosphate is PO4, and he's -3. So how many hydrogens do you need in the front? You need 3. Part G. Magnesium. Magnesium is a metal. His atomic number is 12. What that means to you, you've got an ionic compound and you will need to balance charges. Magnesium, predict his charge. His atomic number is 12. 2+, good job. Sulfate. Key part there is 8. He's on your list. He's polyatomic and he has a -2 charge. When you bring these two together, it's easy. It's like a perfect match. MgSO4. H. Acetic. Alright, kind of like these up here. This came from an acetate ion. Remember the X turned into 8s? So acetate is not made up. It's actually a real ion, and you have to look him up. He ends in an 8. He's on your list. Alright, he is C2H3O2. What's his charge? Just negative. So if he's only -1, how many hydrogens do I need? Just one. There you go. Acetic acid. I. Is I dihydrogen monoxide? Looks like there's a little typo there or something. Hold on. Yeah, I is dihydrogen monoxide. Do you guys know which one that one is? Oops. That's H2O. Di means 2, dihydrogen, monoxide, there's only one, so just H2O. Okay, J is this guy, sodium nitrite. So I'm going to do J down here. Sodium is a metal. His atomic number is 11. So he has a +1 charge. Why am I talking about charges? Well, because I have a metal. Anytime you have metals, you have an ionic compound you have to balance. Alright, let's find this nitride. Who's nitride? Yeah, he is not polyatomic. If he was polyatomic, he would end in an 8 or an ite. So nitride comes from the list. What's his charge? -3. Good job. You have to predict what he will want to do. Nitrogen is 3 away from a noble gas. He wants to gain 3 to be like neon. So when you bring this guy together, you have to balance your charges. You're going to need 3 sodiums, but only 1 nitrogen. Sodium nitride. Alright. Big old grid, just like your homework. A lot of you guys got some feedback on that assignment. Please, 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 let's be careful about overuse of parentheses. That was like the #1 issue that I saw from most people. So, do you guys want me to dive into that grid? Yeah, it looks like a lot of people do. Okay, hold on. Alright, here we go, guys. First thing that I like to do is fill in all of these symbols so that I have them ready to go, so I don't have to keep looking back and forth at my cation and anion sheet. Alright, so let's start with calcium. Calcium is Ca. You have to predict its charge. +2. So remember, you do the number first, charge second, so it's actually 2+. Ammonium. Ammonium is that weird one with the nitrogen in there. This is one of the only polyatomic cations. He's pretty strange. Aluminum. Aluminum is atomic number 13. What's his charge? 3+. Good job, because he's 3 away. He wants to lose 3. Lead. What is this Roman numeral here? Is 4. Good job. So what that means is that this guy's got a +4 charge. Okay. Up on top. Sulfide. Ide ions come from the periodic table. Typically, not always. There's a few exceptions. So you would have to come over and actually predict what his charge is. Ooh. Won't let me erase that, so forget it. So anyway, sulfide is a 2-, monatomic. Hydroxide. I know it ends in an ide, but he's one of those weird ones. He's actually on your list. OH-. Phosphate. 8 ions are on your list. Find him. He's PO4 with a -3. Sulfate. He's on your list. He's an 8 ion. Oxide. Ooh, is he on your list? No. Good. He's monatomic. And he's got a -2 charge. Fluoride. That would be fluorine with a -1 charge. Alright, so now all you have to do is start combining these ions together. So we're going to start moving them together. Remember, don't overuse your parentheses. That's the biggest thing that I can tell you. Alright, let's do the calcium and the sulfide. This is a +2, -2, so it's a perfect match. Let's do the next one. Calcium hydroxide is not a perfect match. You're actually going to need 2 of those hydroxides. Remember, hydroxide's polyatomic. It's 1 oxygen and 1 hydrogen. So biggest mistake that I see is people don't use parentheses on hydroxide. That's usually what I see. Coming over, let's keep going. Calcium is +2. Phosphate is -3. So this is a 3-2 combination. It's pretty tough. Think about the common multiplier is 6. How many of these guys will we need to get to a 6? Yeah, you're going to need 3 of those. And how about your phosphates? How many of those? Only 2. So why did I put parentheses around the phosphate but not the calcium? Yeah, phosphate's polyatomic, but calcium is just monatomic. It's a single atom. Let's keep going. Calcium sulfate is a perfect match. Notice no parentheses around my sulfate because I'm only using 1. Keep going. Calcium oxide, 1 of each. Easy. Calcium fluoride. Now, calcium is +2, but fluoride's only -1. So we're going to match that by adding another fluoride. Let's keep going. Ammonium. A lot of people get confused about ammonium. Just remember ammonium is NH4, so you have to keep the 4 on that ammonium ion. And on the back we're going to put sulfur, but it's not a perfect match. You have a +1 and a -2. So you got to correct that by using parentheses around ammonium because technically ammonium's polyatomic. 1 nitrogen, 4 hydrogens is polyatomic. Keep going. NH4OH, perfect match, +1, -1. Leave it alone, no parentheses. NH4, PO3. See how I'm keeping those subs, or sorry, PO4. Oopsies, I need to erase that. I can't erase, I forgot. I'm on top of an image, so, that's a 4. But anyway, this guy's +1, this guy's -3. So you're getting a whole lot of that ammonium. You need actually 3 of them to match up with that phosphate. So put ammonium around in parentheses if you need more than 1 of it. Let's keep going. Ammonium sulfate. Not a perfect match. This guy's -2, this guy's +1. So you're going to need a couple of those to balance it out. Alright, do you guys get the drift of this particular guy? Yes. Do you want to do one of the leads? Alright, I know which one I want to do. I want to do this one. You have a +4 and a -3. So I want you to think about the number 4 and the number 3. What's a common multiplier between those two? 12. How many of these do you need to get to a +12? 3. So this formula is going to get pretty intense. We're going to get 3 leads. Now, how many phosphates do you think you need? Yeah, you see how it's this guy is a -3. Think about how many you would need to get to 12. Yeah, you would need 4 of those things. Alright, I hope that helps you guys out a little bit. We are running short on time. Let's see what else we have here, because I know a lot of people are worried about this diagram. This diagram is actually pretty easy to understand. So I'm going to take this image and I'm going to copy it, and we'll just have a real quick discussion before you guys are done here. Alright, this diagram is meant to represent bond strength and bond length. So this axis right here, if you were to come straight down this way right here, that would actually indicate how far apart the molecules are. So I want you to label this arrow coming out to this mark right here. This is bond length. Length. But the depth of this dip down here, this valley, however deep that is, that actually indicates the bond strength. The deeper the dip, the stronger the bond will be. Strength. I can't spell. Now, this is when the atoms are really, really close together. In fact, they are too close together. This is where you're going to actually experience repulsion. because the nuclei are too close together, and the protons in the nucleus are going to repel one another. Down here, this is where they have the strongest attraction, and this is where the bond wants to be at. Strongest attraction here. Now, back over here at part C, there's a little bit of attraction, but it's not strong enough to keep the atoms together, so there really isn't a very effective bond right there. Alright, ladies and gentlemen, if you have any other questions about your study guide, feel free to email me at any time. But that's all the time that we had for today. Alright, guys, study up, and I'll see you guys next class.